Okay, our last section we'll look at this weekend, really, for the entire course is section 7.4. There's really no new formulas. There's no notes in terms of like definitions or things like that. It's just examples, like 6 or 7 examples using the stuff we learned last week. So some of the things we want to keep in mind are how to change from log to exponential form. Okay, that's going to come up. Properties of logs, the fact we can combine and split them. Okay, you might need to do that. We also might have to put exponents in front if you have an exponent on an argument. And other than that, the only thing you're going to have to know is stuff from algebra, like solving a quadratic equation, I think, is going to come up. You're not going to need quadratic formula, but you do have to know how to factor. Okay. So we'll go through it. Okay, so let's start with this one. It says 2 log base 5x equals log base 5 of 9. Okay. When we're looking at those equations, okay, we're trying to make what's on the left match what's on the right. That's what equals means. Is there anything there that already matches? Yeah? Log, what is it?
Base 5.
Base 5. Okay, you have a log base 5 on the left, you have a log base 5 on the right. On the right, you're taking log base 5 of 9. On the left, what are you taking log base 5 of? Peter?
X.
Be careful. That's part of it. But there's something else that's written on the left-hand side that really belongs to the x if we use a rule, even though it's not there right now.
X squared.
It's really log base 5 of x squared. Yes. So the first thing we would do is put that 2 back. And we're taking the log of x squared using base 5. And we're taking the log of 9 using base 5. So since the log bases already match, we just have to make that match that. If you can find a number you could plug in for x on the left, square it, and get the same thing in the red box on the right, that's the answer. Does anybody see what you could plug in for x and make it work?
3.
Yeah, x is 3. If you weren't sure, just set the boxes equal to each other. Solve for x. And that's it. If the log bases didn't match, that would be a lot harder. Okay, so in a problem like that, they will match. Okay. Any questions on how we did that one? Okay, so general idea, put exponents back up like we've done before. The bases will probably already match, and just figure out how to make what's in the box on the left match the box on the right by setting up an equation. Okay, so that's first type. All right, let's look at this one. So this one says log base 4 of x plus 3 plus log base 4 of 2 minus x equals 1. Okay, Haley, do I have any numbers in front of the logs that I could put back as exponents? No. So there's nothing to put back up as an exponent here, so we can't use that rule. But we have 2 separate logs on the left-hand side, and they have the same base. So what are we allowed to do with 2 logs that are separate, and they have the same base? We can combine them. Okay, so we're gonna recombine them. When you recombine it, what is the base going to be? The same. The base never changes. So it's log base 4. But now we have to remember how addition combines together. Does anybody remember what operation addition recombines as? Yeah? Multiplication. So it's going to be the log base 4 of, and now we're going to multiply the 2 arguments together. What I'll do is I'll just write them first, and then the next step I'll multiply them, or you could do both at the same time. But I will not. Okay, So now just FOIL or double distributive property and see what we get. So we're going to have log base 4 of page, what's x times 2? 2x. And Molly, x times negative x. Well, negative x times 1 would be negative x. So it's going to change.
X squared.
Negative x squared. So negative x squared, 3 times 2 is 6. And lastly, Connor, what's 3 times negative x? Negative 3x. So really, what I have is a 2x combined with a negative 3x. So what I'm going to do is I'm going to combine them in this step so I don't have to write it again. 2x minus 3x is really just minus x. Any questions on that? All right, so we don't have any numbers in front. We can't move those back as exponents. We don't have two logs that are separate. We've already combined them. There's only one other thing we can do with an equation that's in log form. What's the only other thing we learned we could do? It's what we learned the very first day. It's the very, very first thing we learned about logs. Something I reviewed right before we started. And we had the A, B, and C. What did we review? And I had log, and I had the A, the B, and the C. I used those 3 letters. Peter, do you remember?
Exponential.
Yeah, change it to exponential form. Okay, that's the only thing that you can do that's left. So we have 3 things, right? There's our base, there's our argument, that's the thing on the other side. All right. So Brian, what's my base? 4 is my base. About Victoria, we said logarithms always equal what kind of number?
Maybe not. Logarithms always equal like above 0.
This number on the other side, that could be negative. So it's not positive or negative, but that number is always an, that's a hint. It's always, this number is always an, Ryan?
Exponent.
Exponent. Okay? Logs always equal exponents. So that's my exponent. 4 is my base, 1 is my exponent. And Cameron, what does that mean would go on the other side?
The argument.
The argument, which in this case is?
In parentheses, negative x minus x squared plus 6.
Yeah, I'm just going to write that the way we normally write it when we write a quadratic equation. Highest exponent first, then the linear term, and then the constant. Okay, from here, we're done with the stuff I've taught you. You have to know how to solve a quadratic equation from there, okay, from Algebra 1. Generally, when we solve a quadratic, we like to get it equal to a certain number. Right now, it's equal to 4. 4 to the first power is just 4. Well, we don't normally get it equal to 4. Does anybody remember when you solve a quadratic, what you normally get it equal to?
0.
You get it equal to 0. So we're going to put everything, I'm going to move everything to the left. Okay, you might just say, well, why don't you just move the 4 to the right? It's easier. Well, I don't like that. Okay, when you get into factoring, you don't want the x squared to be a negative. In Algebra 1, you always solve it when that's a positive. So let's move everything to the left, and that'll fix that problem. So I'm going to add the x squared. Just make a column of everything I'm going to add. I'm going to add the x, and then I'm going to subtract 6. Okay, so that's all going to cancel. And I'm going to get x squared plus x. I have 4 to the first power, which is 4, take away 6. 4 take away 6 is negative 2. All right, so one way you can solve a quadratic equation that will always work is the quadratic formula. Sometimes, if you have the right numbers, you can factor it, and that's a lot faster. So let's see if we can factor this. Emily, what would be my first term in each parenthesis?
X.
Yep. So we need an x and an x. I have a positive middle and a negative constant. Cameron, do you remember what that means my signs have to be when I factor?
Opposite.
Yep. Opposite. And Connor, what are two numbers that multiply to give me 2 and subtract to give me 1? 2 and 1. And do you want to, it does make a difference which one we put where because the signs are different. So do you want to do 2 and 1 or 1 and 2? Yeah, no, I think that'll work. 2 and 1. Just had to think in my head for a second. So we get x squared minus x plus 2x. Minus x plus 2x is a plus 1x. Perfect. All right, so now we factored it. And now we have to do something with each of these factors. The x plus 2 and the x minus 1. Anyone remember what we do with each one of those? Yeah? Right, you set them equal to 0. Because you have something times something giving you 0. The only way you can multiply two things together and get 0 is either that must equal 0 or that equals 0. And we're going to get two answers. So we get negative 2 or 1. Now, let's go back up and keep in mind the argument to a log function has to be positive. If it's not, you're going to get an imaginary number. So let's check our 2x values and make sure we don't get negatives when we plug them in. Let's start with the first part. Negative 2 plus 3. Matt, what's negative 2 plus 3?
1.
Positive 1, so we're good. It's going to be okay there. Let's try the next part. Ashton, what's 2 minus negative 2?
2 minus negative 2 is 0.
That would be 2 minus 2.
Oh,
But 2 minus negative 2. 4. So we're okay there. All right. So we did not get a negative, so that means this answer works. Is that always going to work? No. Okay. Sometimes you're going to plug the answer back in and get a negative, and that's not good. So let's try x equals 1. 1 plus 3 is 4. We're good. 2 minus 1 is 1. We're good. In this case, both answers worked. Okay, 3 things can happen. That's 1. They both work. The second thing that can happen is 1 works and 1 doesn't. Or the third thing is you try them and they both don't work. Does anybody know the symbol that you write if you have no solution? Sometimes when you try to solve an equation and there's no answer to it, they write this symbol. In math, the symbol means, the name, well, it means empty set. Anybody know what that symbol is? It means kind of like the set of solutions to the problem is empty. There is no solution. People seen that before? That symbol? Yeah, that symbol means empty set, means no solution. So, if it's a multiple choice question, and you see that as a choice, that choice means there is no solution to the problem. That would happen if you plug these in and they both came out negative. Not if the answer is negative here, but when you plug it in. do you get a negative? Okay. So let's say inside the argument you had x plus 1. Let's say that was one of your arguments. If you try to plug -2 into that, you get -2 plus 1 is -1. That's an example where it would not work. Okay. Any questions on that one? Okay, not too bad, but it's definitely a little harder than the first one because you have to know how to solve a quadratic equation, either factoring or quadratic formula. And that's what we just did. Check to make sure you're not taking the log of a negative. All right, let's try this one. Log base 3 of x equals 9. Hey, Emily, do I have multiple logs in this problem? No, I only have one log, so the rule for combining logs doesn't apply. There's nothing to combine, it's already combined. How about Rudy, do I have numbers in front of the log that I could put back as an exponent on the x? No. So there's nothing I can do there. There's only one thing left I can do. Yeah, make it exponential. Can you tell me what's my base, Alex?
3 to the 9 equals x.
That's it. That's the answer, 3 to the 9th power. If the answer comes out small enough, they'll have you do it out. So 3 to the 9th. It's not, I mean, it's a big number, but it's not like it's in the billions. So we could write that one out. 19,683. So if it's a short answer question, the directions will say whether or not you should do it out. If it's a multiple choice question, just look at the choices, and if they do it out, then you do it out. Okay. Any questions on that one? Okay, so I'd say that's more of an easy one, okay, like the first one. You're going to do some that are easy and then some that are definitely a little harder. That one's pretty straightforward. But it's not one that you could guess the answer to. Right? If I gave that to somebody who doesn't know logs, they'd say, well, I could try 2 to the 2nd power. That gives me 4. So that's too small. So let's try the next number up, 2 to the 3rd power. That gives me 8. That's too big. So now I know the answer is somewhere between 2 to the 2nd power and 2 to the 3rd. So it's between 2 and 3. But we have to figure out exactly what it is. How about, Alex, what kind of equation is that? We talked about 2 types this week and last week.
Oh, it's exponential.
It's exponential. What's the other type?
Logarithmic.
Logarithmic. So let's change that to a log equation, because that's the only possible thing we know how to do. The other hint is anytime you have a variable that's an exponent, think about what I keep saying about logs. Logs equal exponents. So if you want to find out what an exponent equals, then a log will do it. So we're going to change it to log form. Yeah, Rudy.
Log base 2
Yep.
equal to x, and then 5 is everything.
Yep. So my base is 2. Logarithm always equals the exponent. My argument is 5. Now, what's the problem with that base? Why can't I just type that in easily? Yeah.
It's not 10 or E.
It's not 10 or E. So somehow we have to rewrite that so we can type it in. Okay, and we reviewed that in the homework. Yep.
Log 5 over log 2.
And what base are you assuming?
Base 5 and base 2. Oh, of x.
Well, that's equal to x, but what's the base on each log? Because it's got to be a base we can type in now.
I thought it was just going to be base 5.
No, because we can't
Okay.
type base 5 in.
Base 10.
What invisible number is right there?
10.
10. So we're doing log base 10 of 5 divided by log base 2. Log base 10 of 2. Okay, so we're doing base 10. So log 5 divided by log 2. So be careful with your parentheses when you type that in. And you get 2.32. Most of the time on a problem like this, they're going to have you do the decimal out. They're not going to leave the answer as a fraction. Okay, so very easy question as long as you know how to type that in using the change of base formula. Any questions on that one? All right, let's try. One's pretty much the same. Yeah, that one's pretty much the same too, but it's like one extra step. Okay, so you can call this example 5. Anyone think they know what the extra step you have to do first is in this problem versus a problem like this? It's one thing. Ashley?
Would you have to divide the 8 first?
Yeah, the goal is to get this by itself. Get as many things away from the x as you can. So one thing I can get away from it is the 8 by dividing. Now I have a number to a power equals a number. That's exactly what I just had right here. A number to a power equals a number. So now look at, let me see if I can get both of these at the same time. Okay, if you look at the pattern for the one on the left, log of the number that's by itself divided by the log of the base. You can really just jump right to the final answer here. Log of the number that's by itself divided by log of the base. If you don't want to do it that way and you want to go through that step in the middle, like changing from exponential to log form, you can do that. But it's exactly the same pattern as the one we just did, so I'm just trying to use a shortcut. Okay, so let's see what we get. Log of 5/8. Maybe? No? 8 divided by log 3. Log 3. It's not as important I close the parenthesis at the end because there's nothing coming after it, but if you want to, you can. And we get negative 0.43. Any questions on that one? All right, so again, pretty straightforward. One extra step, just dividing by 8 in the beginning. This one, let's take a look. All right, this one, in terms of the algebra, it's not going to be anything really beyond algebra 1. And what I'm going to do is I'm going to do an algebra 1 problem kind of side by side with it, like a simpler one, so you can kind of jog your memory about what to do. But you're going to have the word log written a lot. Okay, you're going to have it written in like 4 different places, so it's going to look more confusing than it really is. All right, the major problem with this is the bases are different. If the bases were the same, this would be extremely easy. Like if I had 5 to the x minus 2 equals 5 to the 3x plus 2, since the bases already match, all I have to do is find a number that I plug in here and plug in here and get the same answer. So all you'd have to do is this. Solve that, and that would be your answer. But the bases here are not the same. So we can't do that. So I have exponents. And what's a rule that we can do with exponents? What are we allowed to do with an exponent? Think about what we did on this problem. First one we did. About Katie? What are we allowed to do with exponents? Well, what did we do on that example? What did we do on that example? Kind of in reverse. Well, we had a number in front and it became an exponent on the argument. Right? So we are allowed to take exponents on the argument and move them in front. In this problem, I did the reverse of that. But in this one, I want to move those exponents in front. But why can't I just move them in front right now? I can't just take the x minus 2 and throw it in front. How come? Yeah.
It's an exponential one.
Okay. Can you say more? Ryan?
Because it's like not in log.
There's no logs there, right? The only time you can put exponents in front is if the exponent comes from something that had a log. Okay? There are no logs in this problem. So what I'm going to do, something that's a little different, but we haven't done it in this class, is I'm going to take the log of each side. Remember, from algebra, as long as you do it on both sides, you're okay. Okay, you got to just balance it out. So let's take the log of the left and take the log of what's on the right. And I'm going to do log base 10. All right, so we have log of 5 to the x minus 2 equals log of 3 to the 3x plus 2. Now I can put the exponents in front, okay? Because I have a log on each side. And that's going to get rid of all my exponents. So I have x minus 2 times log 5. And I have 3x plus 2 times log 3. Now, anybody know what property we're going to use next on both sides? Well, this is where I said I'm going to kind of put an Algebra 1 problem side by side. And let's pretend this was the problem. This is not the problem, but pretend that you had something like this. If the problem was the one on the right, what would you do with that one on both sides? Yeah, distribute. Right? You would distribute the number that's on the outside of the parentheses to what's on the inside. It's exactly what we're going to do here. Okay, remember, log 5, I'm not going to write this down, but log 5 is just the number, think of it as 0.7. All I'm really doing on the left is distributing 0.7 to each number, and then whatever log 3 is, I'm going to distribute that. What's going to make it look more confusing than it is I'm not going to write what log 5 is. I'm just going to leave the word log 5 for now. So let's multiply that up. So we get log 5 times x minus log 5 times 2. And do the same thing on the other side. We're going to get 3x log 3 plus 2 log 3. Alright, so now let's pretend we did that on the right, and we have 5x minus 10 equals 9x plus 6. So now when you're solving an equation, what's your next step? Again, pretend like you're looking at the one on the right. It's going to be exactly the same as the one on the left. Peter?
Get all the x's on one side.
Exactly. Get all the terms that have x on one side. Get all the terms that don't have x on the other. Okay. So what I'm going to do is I'm going to put all the x's on the left. Okay, so I'm going to minus 3x log 3, and I'm going to minus 3x log 3. There's nothing I can really do to combine those, so I'm just going to leave that. I'll rewrite it nicer in a second, but I can't combine it. If I put all the x's on the left, I'm going to put things without x's on the right. I'm going to add 2 log 5, and I'm going to add 2 log 5. Again, nothing I can really do to combine it, so we'll just leave it. So, x log 5 minus 3x log 3 equals 2 log 3 plus 2 log 5. So now we have things with x on the left, things without x on the right. Let me do the same thing with this algebra 1 equation. Okay, and I'm going to do it exactly the same way. I'm not going to combine anything. I'm just going to leave it. So I'm going to minus 9x minus 9x. I'm going to plus 10 plus 10. So I'm going to leave that as 5x minus 9x equals, let's see, that was 6 plus 10. Okay, I'm just going to leave it to try to make it look very similar to what I'm doing here. All right. Now, look at the algebra 1 type equation. Look on the left-hand side. What do both of those terms have in common? Yeah. X. Now you might be like, well, why don't you just combine them together? And then you can just divide by whatever number's in front. Because I can't combine them together with the log equation. So I'm showing you how to solve this algebra 1 equation, exactly the same steps as the log equation. So they have an x in common. I'm going to factor that out then. Okay. If I factor it out, I'm left with that. Okay. Check it. X times 5 is 5x. X times negative 9 is negative 9x. Okay. Leave the other side the same. Right. Let's do the same thing here. Factor out the x. If I factor out the x from the first term, what am I left with? Yeah. I'm left with log 5 minus, and if I factor it out from the second term, what's left? A little more than log 3. Something else is in front of it as well. 3 log 3. Keep the other side exactly the same. 2 log 3 plus 2 log 5. Again, what you're looking at in this step and what you're looking at in that step are the exact same problem in terms of what you need to do. Don't get confused because you see the word log written everywhere. That's, I think, what confuses people the most. All right. So now look at the structure. Letter, all that stuff in parentheses is a number, equals another number plus another number. It's exactly what I have here. X, all that stuff in parentheses is a number, equals another number plus another number. All right, so the last thing I want to do is get rid of the number next to x. So how do we move the number next to x to the other side? Yeah?
Would you divide?
Yeah, you divide by it. Now, I know that 5 minus 9 is negative 4, but pretend you couldn't combine them. Just divide by the number, whatever it is, and then divide by the number. And there's the answer to the problem. Now you can do all that out. Okay? So let's do it here. Divide by whatever the number is next to the x. In this case, it's not 5 minus 9, it's log 5 minus 3 log 3. And do it on the other side. Log 5 minus 3 log 3. Now you can do that all out. Just like on the other side, now you can do out 6 plus 10 and divide by 5 minus 9. It's kind of a pain to type all that in because it's a lot of stuff to type in. But if they wanted a decimal out, I'll go through it and just show you how to type it in. I'm not going to do it all at once since there's so many logs there. I'm going to do it in 2 steps. Let's do 2 log 3 plus 2 log 5. So the top is 2.352. Since I use 3 decimals, that's accurate enough for what we're doing. And the bottom, log 5 minus 3 log 3. So the bottom is negative 0.732. And now just divide that. 2.352 divided by negative 0.732. Okay, so we get negative 0.321. Negative 3.21, sorry. Okay, and that's the hardest one we're going to do today. But I really think if you think about it and pretend that the word log isn't there and think of it as an Algebra 1 problem, it's a lot easier. Don't let the word log written in 4 different places confuse you. Okay, so any questions on that one? Okay, so it's a little tricky, but general steps, take the log of each side, put the exponent in front, and then from this point down was all Algebra 1. Using distributive property, getting all the x's on one side, factoring, and then the last step was a division. These are the only steps that are really trig or somewhat trig related. Actually, not even that step. Just those 2. Okay. All right, let's take a look at another one. What's a little different about this one? Something happened in example 8 that usually doesn't happen, but it is here. Yeah?
Logs have different bases.
Right, the logs have different bases. So if you look at example 8, or whatever number, I think it's actually 7, because we skipped one. But if you look at that one, you have a log plus a log equals a number. And then if you look back at example 2, a log plus a log equals a number. If you look quickly, you might say, oh, it's the same kind of thing. Not really. Okay, that one, the bases are the same. This one, the bases are different. So you cannot use your rule to combine them together. And the only thing we could do with this, and the first thing you'd have to do, is write everything with the same base. How do you do that? Well, use the change of base formula on that part, and start by writing it like this. Now, everything there is a base 10. Use the change of base formula on that part. Log of x over log of 4 equals 4. Now, everything there is a base 10 as well. Okay, and solving that would be very similar to solving something like this. Generally, the way we solve an equation that has fractions is we like to get rid of them. Well, you multiply everything by the least common denominator. So in this case, if I multiply everything by 12, that would cancel all of my fractions. 12 goes into 3 4 times. 4 goes into 12 3 times. And 4 times 12 is 48. If I were to finish this problem, it would be the same idea. You'd multiply everything by the least common denominator, which is log 3 times log 4. 3 times 4. That's how I got the 12. Log 3 times log 4. The only thing is you can't combine log 3 times log 4. And then once you do that, you'd have something very similar to this. You'd have no fractions left, and you'd have something you could solve. So even though the bases are different, start with the change of base formula, and you could solve it. All I want you to be able to recognize in this problem is that the bases are different, and you cannot just combine them the way they are. That's all I want you to know. Okay? Any questions on why you can't combine them? All right. Let's look at that one. It says x plus e to the x equals 2. And the problem with this one is there's an x in 2 spots. And we can have problems with x's in 2 spots like this. Well, that's okay because you can combine them. And you can make it 1x, not 2 of them. Well, you can't really do that here. If this x wasn't here, then it would be very easy to solve. Because e is just the number 2.718. Subtract 2.718, you're done. That'd be the answer. Or, if that x wasn't there, it would be easy to solve because that's exponential form. A number to a variable equals a number. That would be exactly like this. A number to a variable equals a number. We could solve it by changing it to log form. But the problem is we have the x in both spots. So this isn't really a problem that can be done using algebra. Okay, I'm not even sure how to solve it with algebra. I don't think you can. But another way we can solve problems, and in pre-cal we use this a lot, is a graphing calculator. So all I want you to understand here is there are other ways to solve problems besides using algebra. Okay, I'm going to show you just because it's really easy and it's the last thing we're doing today. If I wanted to solve that and somebody said, just get an answer and round it to 2 decimal places, what I would do is type in one side of it, draw a picture of the left-hand side. Let me show you what the left-hand side looks like. That's a sketch of the left-hand side of that equation. It kind of looks almost like a straight line, but then it curves. Now I'm going to draw a sketch of the much simpler right-hand side, which is just a horizontal line at 2. And where do you think the answer to the problem is? Yeah?
Where they intersect.
It's where they intersect. Trying to find where this side equals that side. Well, as a picture, where 2 things are equal, it's where they cross. So the calculator can this kind of calculator can automatically tell me where they intersect just by doing second calc intersect, and it tells me the intersection is at 0.44. Again, how would you do that with algebra? I'm not really sure. You can, but you can definitely do it graphically. And there's other methods to solve it as well, just not with the kind of algebra that we know at this point. So all I want you to understand here is there's certain kind of problems you cannot solve very easily, if at all, with regular algebra that you know. Okay. Any questions on what the problem is, why you can't solve that with regular algebra? this one's more like example 2, where you have two logs with the same base, and you get one of three things that happens. Both answers work, both answers don't, one works, one doesn't. Does anyone want me to go through that one? I think the one I gave you in the notes, both answers worked. I think this is the case where one works and one doesn't. I just remember from doing it in the past. There's no way to tell by looking at it. But I just think one works and one doesn't. Go through it? Okay. So we'll look at it quick. There's your two arguments. Those are going to recombine. And when I recombine them, how does addition combine again? As multiplication. So I'm going to distribute it as I go. It's x squared minus 3x. Okay. So any question on that part? Now rewrite it. 4 is your base. 1 is your exponent. X squared minus 3x goes on the other side. Okay, so now we've got a quadratic, but this quadratic is equal to 4. Usually when we solve a quadratic, we get it equal to 0. This time, move everything to the right so you can keep the x squared positive. I need two numbers that multiply to give me 4 and subtract to give me negative 3. Two numbers that multiply to give me 4 and subtract to give me a 3. The order just depends on the order you subtract it.
4 and 1.
We got to use a 4 and a 1. Yep. Negative middle, negative constant. Means your signs are one of each. So it does make a difference where you put the 4 and the 1. I would do it like that. You get x squared plus x, take away 4x. That's negative 3x. How about Connor? What value of x would make the first factor 0? What value of x would make that first factor 0? Well, let's check it. Is 0 minus 4 give me 0? No.
Oh, 4.
4? And what about the second factor? Negative 1. So those are my answers, but make sure they don't give you any negatives. Let's check 4. If I plug in a 4 for x page, would that first circle be positive? How about if I plug in a 4 for x here? Would that second circle be positive? Yeah, 4 works fine. Let's check negative 1. If I plug in negative 1, that first circle is negative 1. No. And then the second one would be negative 1 minus 3 is negative 4. No. That answer does not work. Okay. So that's the case where one works and one doesn't. Questions on that one? Okay, and that one, I'm not sure if that was one from the homework. That was number 10. No, I skipped. I took that one off. So you don't have to do 10 because we just did it. So homework on 490. 1 through 3 all. 5, 6, 9. And then 17 through 21 odd. Okay, so it's nine questions. I will be after school today if anyone needs extra help. And you've got about 15 minutes or so. So some extra books on the counter. If you need any help or anything you want to ask me about the test this week, let me know and I'll come by and help you out.